All right, good morning. Let's go ahead and start what we're doing today, which is solve systems of equations by elimination and solving word problems using the systems of equations. So yesterday we talked a little bit about the substitution method and the graphing method. So this is the other one. Elimination method is kind of, I don't know if it's easier or faster, but for some reason I think more people just prefer it, I guess. And I don't know. Maybe it'll probably be the same for you. But what you do is, first thing you got to do is line up the equations. Now, when it says line up, that means they have to be in the same order. All right. So if it's like slope-intercept form, then they both need to be slope-intercept form. All right. If they are both standard form, then you have to make both of them into standard form, okay? But, or whatever form you have, they just have to be in the same order. So like let's say x equals y plus b, or something like that, or c. Then the other one has to be that exact same order of x equals y plus b, or whatever you have. They just have to match. Every single thing of them has to be in the same part. Every element, every term needs to be in the same spot as the other one. Anyway, that's the first part, line them up. The next part is multiply them. Sometimes you might have to do this to one or both of them so that you get so you get one variable that has the same number in the front, the coefficient. And then you have to have one of them be opposite. So one of them has to be negative, the other has to be positive. And then you add or subtract all of the things. You combine every piece of those equations, and that will cause one of your variables to drop out. When that drops out, well, that's why it's called the elimination method. And the next thing you do is you solve for the remaining variables. So just like substitution, you kind of have to get rid of one of them because you can't solve when they're both there. And then lastly, substitute for the answer that you got to get the other one. So take what you have and use it to help you get the other one. Okay, so let's go ahead and move into some of the exercises. So again, first thing you got to check is you got to check to see if they are in the same order. So in this case, they are the same order. X plus y equals c. X minus y equals c. Now, be careful, because this is the one thing that I see a lot with, whenever I do this, this is the one thing I see the most often, and that is the equal sign will sometimes be in a different place, but all the terms will line up. So when you do that, you got to make sure the equal sign lines up also. So I have two choices. I can either eliminate x or I can eliminate y. Now, the thing that it says here, multiply both of them by a number. That was the second step. We're trying to get one of these to eliminate. So what I'm going to do is I'm going to multiply everything by -1 for the bottom one. And why I'm doing that is because I want this x to be a negative. Since this top one is positive, this one will be negative. And when I combine them, then it will drop out. It'll eliminate. But that's going to cause me to have to switch the signs on everything. So x is now negative, y is now positive, and 7 is now positive. And I'm going to go ahead and remove these. You don't have to do this. I'm just doing it so it's easier for you to follow along. But anyway, yeah, the signs of everything has been reversed now. So the next thing I need to do is combine each part. So x minus x, our first term here, x minus x is, well, nothing. It's 0. 0x. And that's why it eliminates. Here I get 7 y plus y. So 7y plus y would be 8y equals 17 plus 7, that would be 24. Wait, yeah, okay, that is 24. Think about that for a second. And that makes sense. As far as I know, again, most of these are going to be whole numbers. although I think there are going to be some fractions as well. And keep going. So I'm going to divide both sides by 8. So y equals 3. But again, we're only halfway done. Well, not halfway done. Like, this is not half of the work. After this, it gets pretty easy. Now, I'm going to go ahead and plug it back in to, let's use the bottom equation. So for the bottom equation, I'm going to go ahead and plug it in. So I'm gonna bring back the original equation, and that's kind of what I said yesterday. When you're doing this, bring back the original equation. And in this case, I wanted to use the bottom one because it's just got the smaller numbers. And x is already positive. Well, I guess the top one would have worked also. Well, they both will work. Okay, they'll both work. They'll both give you the same answer. They're both talking about the same lines, so it's not like it's going to be really tricky in that you can get the wrong answer just by following the steps. So in this case here, I got x equals -4. And remember, when you get the solution, you have to put them into an ordered pair. So ordered pair, -4, means the x goes first and then the y. So now we have our solution in an ordered pair. So -4, 3. So if this was a graph, that is where they would end up at. So -4, -4 up 3, something like that. And there you go. All right, so let's go ahead and do number 2. Now, again, where elimination is best, okay, elimination is best when you have 2 terms of the same variable that are equivalent. And in fact, in this case here, I don't even have to do anything at all. I don't have to multiply both sides because I have positive 2y and negative 2y. Since they're the same term but opposite, right? One is negative, the other is positive. I can just go ahead and add everything else. I don't have to change anything. It's already basically set up for me. 3 and 5 is going to be 8x. And here, add these two together. So 2 and 2 is 4. And 2 and 4 is also going to be 64. And if I asked you what number can I times by 8 to get 64, you probably wouldn't even miss a beat. So there we go, x equals 8. And I got my first one. Now I just gotta go ahead and plug it back in to find the other one. So like I said, sometimes you can find one and use it to help get the other one. And now I just gotta pick one of my equations to plug it into. Now since I'm gonna plug it into 8, it would probably make sense to, in this case, I don't really see any of them that are easier than the other. So I'm just gonna go with the top one only because we used the bottom one the last time. And the numbers are a little bit smaller, but in this case, I don't think that's really gonna help out significantly. So 3 times 8 plus 2y equals 22. I also wanted to pick the top one because the y is already positive. That way I don't have to divide both sides by a negative. All right, so 24 plus 2y, because 3 times 8. And now I got to get rid of this 24, so minus 24 on both sides. So 2y equals negative, I can tell it's going to be negative, but it looks like -2. Y equals, and I'm going to have to divide both sides by 1. And -2 divided by 2 is going to be -1. So it looks like I have both parts of my solution now. So I got my x value, which is 8, and my y, which is -1. Let's go ahead and box that up, and that's it for that one. Okay. go ahead and move on. Did you have a question? Okay. And don't forget, you can ask questions or leave something in the chat as well. So let's go ahead and look at this one. So, now I don't have anything that's really set to eliminate. So 4x and, well, 1x, 5 and 9y. So I don't have anything that's set to eliminate. I'm gonna have to change one of these to make it work. Sometimes you got to do a little bit of thinking. So I can't really, if I wanted my y's to match, I couldn't just double one of them and have it match, because if this was like 10y, that would be a lot easier. So y is out of the question. Let's look at x. So with x, I have 4 and 1. So in this case here, it looks like I'm going to have to times everything by 4. But not just any 4, because in this case here, my first term, 4x and 4x, is not going to eliminate, because if I put 4x and 4x together, I will get 8x, not negative 4x is what I need, right? That's what I need. So if it's negative 4x and positive 4x, then it will eliminate. That's what I'm trying to do. So I'm going to have to change this bottom one all the way. So I'm going to go ahead and write it here. So negative 4x. And multiply here, so negative 20y. And last one here is negative 16. All right, double check it, because it's really easy to lose negatives here. So just check your signs, positive, 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 negative, negative, negative. All right, so we made sure all of our signs are there. Ignore this. Okay, now don't scratch it out. If you're following along with your packet, don't scratch it out, because you will need it later. I'm only doing this so that I can see the top and the bottom, and so that way people can see the top and the bottom ones a lot easier. Or I don't know, I'm just going to leave it off. So let's go ahead and combine them. So we're ignoring that middle part. 4x minus 4x. Okay, that's going to be 0x. And negative 9, negative 20 is going to be negative 29. So negative 29y. And now I'm going to put these together. So negative 42 and negative 16. So 6 plus 2 is 8. And they're both negative, so they're going to add just like they would add regular numbers now. That should be negative. I should have put enough room in there for a negative, but I didn't. So you just have to remember that that negative, that 58 is negative. Divide both sides by 29, but also negative 29, because I want to get rid of this negative as well. And y equals 2. All right, so there we go. We got the first one. Now we have to go back and get the other one. Now for this one here, I'm going to go ahead and erase this, because I kind of want to use this bottom one here. I don't know if it's a good idea to erase it, but you know what? I'm gonna just plug it in. So x plus 5y, but instead of y, we're gonna get 2 equals 4. So I plugged in y for 2, and I'm just going to use the bottom one. To me, that just looks like a slightly easier one to work with. X plus 10, because 5 times 2 is 10. And what number can I add to 10 in order to get 4? Well, looks like we're going to have to minus 10 from both sides. And we get negative 6. X equals negative 6. And there we go. Now I think we have both parts of this solution. So negative 6 and 2. All right, next one. Let I'm gonna move this over just a little bit. Hey, no tickling. All right, leave the other students alone. Hey. Okay, let's go ahead and do this side here. Now, if we look at 7 and 2x, that's going to be a tough one because the only number I could make them match up at would be 14. So if I wanted them to match at 14, I'd have to change both of them, which is sometimes something you have to do. Sometimes you have to change both of them. But in this case, we always want to try doing things the simple way first, right? Try the easiest methods and kind of work upwards to that, to the harder methods. So let's, again, keep it easy. So I don't want to change the x's, but looking at the y's, I can see that one is 6y and 3y. We can make those match. I would just have to double the bottom one. So that's what we're going to do. We're going to go ahead and double this bottom one, pretty much the same way we did here. And not just double it either, but I also want to make it negative as well, because if they're both negative 6y, that's not going to help. I need one to be positive and the other to be negative. So the only way I can do that is if I multiply negative times a negative, then it'll make it positive 6y, then they will eliminate. And once they eliminate, that's good. Because again, you can't solve these if you have two variables. So that's why you have to kind of get rid of one. So negative 2 times positive 2x, so that'd be negative 4x plus negative 2 times negative 3y, so that'd be positive 6y. And next one, negative 2, negative 13. So in this case, that would be positive 26. Double check it, make sure that I moved all the signs. And with these ones, again, I highly recommend you double check them, because even I do it because, well, you know, I'll make mistakes every now and then too. All right, so it looks like we got everything right. Let's go ahead and get that top equation and that new one we made put together. So 7x minus 4x. And in this case, that would be 3x. Just write a little barrier here so so I can separate the work. And then y, so negative, now remember, we're ignoring this middle one. And this would cancel out. It's negative 6y plus 6y, yeah, that's gonna cancel out. And 26 minus 53. All right, so I know it's going to be a negative number. But the question is, what is it going to be? So 53 minus 26, so 13 minus 6. 13 minus 6 would be 7. And since I borrowed from here, that would be 40. So 40 minus 20 is 27. Okay, so that makes sense. And let me go ahead and divide both sides. So it looks like I'm going to have to divide both sides in order to get a 3. X equals negative 9. All right, looks okay to me. Now let's go ahead and go back into the original, one of the originals, and I want to use the original one of this one here. So 2x minus 3y equals negative 13. And I want to put negative 9 in there because now we know that x is negative 9. So we're going to use that to help us find the y. So 2 times negative 9, and double check my signs in this case. Looks like negative 18 minus 3y equals negative 13. All right, now it looks like we're going to have to add 18 to both sides so that we can get that y value. Negative 3y equals, and 18 minus 3 is going to be 5. And it looks like we're just going to have a, what do you call that thing? A fraction. Just, the word just slipped my mind. Divide both sides by negative 3. And it looks like we have our parts for the ordered pair. Now, in this case here, 5 divided by 3, well, you can fit it in there one time. And 5 minus 3 would be 2. So that'd be 2 out of 3, so 1 2/3. And in this case, I'm just going to go ahead and use a fraction, just because, well, we're done with this. We don't need to work with it. Sometimes, like if you want to add another number and it's going to come out to be a whole number, then it might, or at least a fraction you can work with on a calculator, then it might be worth it. But in this case here, not really. Okay, so what I'm going to do now is I am going to go ahead and switch over to Desmos. Come on, why is it not sharing? All right, so hopefully, I think you can see it now. So I'm gonna type in what we had from this problem, just to check it. And this is something you can do with pretty much all of the problems. 7x minus 6y equals negative 53. And now I'm gonna go ahead and type in the next one. Oopsie, what did I do? Oh. Okay, I didn't know you could do that. That's useful to know in case I need to turn off a graph. All right, so let me just double check the writing, make sure it's all there. And there we go. Now remember, the answer was negative 9 and 1 point, well, it'd be 1 2/3, which here it comes out to be negative 1.667. And it was negative on there too. And actually both of them were negative. So negative 9 and negative 1.667. So there we go. We checked it, right? Because I did say that some of these might be fractions. So don't discount them if they are fractions, I guess. Sometimes it's just, you'll get them. All right, so let's go ahead and go back here and move to another set. Solve by elimination, same thing. All right, so let's look it over. Now, I can't double this to get 5, and I can't double 3 to get 7. So it looks like we're gonna have to multiply everything, or I'm sorry, both equations. We're gonna have to do something on both equations to make this work. Now the question is, what are we going to multiply both sides by? So I'm thinking we can get this x here to be 10 or something like that. So I'm going to multiply the top one by 2, so that way we get 10x. And I'm going to multiply the bottom one by negative 5, so that I get negative 10x. So again, they have to be the same number, but opposite. And this looks like I'm going to have to rewrite both equations, which is, it's going to take a while. So 2 times 5x is 10x plus 6y equals negative 14. And then again, double check the signs, make sure everything got doubled. All right, now for the bottom one, negative 10x, which again, that looks to a good start, negative 35y. Equals negative 15. All right, now we got both of them. Double check our signs. Let's go ahead and combine these and see what we get. So let's see. Negative 35 plus 6. So it's 35 minus 6, which is 29. But it is going to be negative, so negative 29. And here I have two negatives, which also looks like it's going to be negative 29. Since they're both negative, it's going to combine to make a bigger negative. And this one's pretty easy because they're basically the same thing. So anything times 1 is going to be that same number. So we're going to use identity property, and we get 1. Now be careful, because I could imagine some people confusing it with -1. But if it was -1, then negative times negative would be positive and not negative. So there we go. I'm going to go ahead and plug it back into one of the equations. I guess I'll just use the top one for now. 5x plus 3y. And I don't know what the y is, or actually I do know what the y is, so I'm going to plug that in there. So let's go ahead and drop that y right in there because it's 1. 5x plus 3 equals -7. Well, okay, timesing something by 1 is pretty easy. Or wait a minute, did I? Okay, I guess that works out. -3 on both sides. So 5x equals -10. And divide both sides by 5. And x equals, I'm going to write it off to the side here because I want to put my answer over there, -2. So when I write the ordered pair, again, make sure that you put the x first and the y second. And there we go. Now we have -2, 1 as our answer for that one. Whew, okay, so again, sometimes you just got to change both of them. Looking at number 6, I got to have one of these cancel out. And let's see, positive 4x, 3x. Okay, so I'm going to have to change one of these to negative, because if I look at the 9 and the 12, they're both negative y numbers also. So I'm going to have to change one of these to a negative. And the question is, which one should I get rid of? Now, I'm thinking I want to get rid of the x value first. To do that, I'd have to just multiply this entire thing by 4 and multiply the bottom one by 3 so that they both be 12. And I'll make that one negative. Okay, so let's go ahead and quadruple everything on the top. 12x minus 36y equals 36. And let's go ahead and change the bottom one, -12x, because we're multiplying everything by a negative, so we got to pay extra attention to that. And here, wait, hold on. 3 times 12, 3 times 12, 24, 36. Okay, a bit of an alarm is going off in my head right now, because normally when you see something like that, it can mean something different is coming up. Because taking a closer look at it, it looks like x and y are both gonna cancel out. Because 12 here minus 12, that's gonna be 0x, and 36y minus 36y, that's gonna make our y cancel out. So in this case, we get something like 0 equals -72. And remember, whenever we run into something like this, where it is an untrue statement and we lose the variable, or variables in this case, that's going to be a, oh, come on, text tool, no solution. So in this case here, there was nothing we could really do about this. We lost our variables. And seeing how they have the same relation between x and y, that's kind of a hint that if I were to put these into slope-intercept form, that they would have matching slopes. Or again, I can just graph it on Desmos and see that there is no parallel, or sorry, there's no intersection, because they are parallel. So again, sometimes it'd be like that. Okay, looks like we got a few more. Oh, yeah. Ooh, all right, let's go ahead and okay. So remember the steps that they gave us in the beginning. We got to make sure they're in the same order, or what do they said line them up. That's the word they used. So in this case here, it's not lined up. 5x, or if I just looking at the variable x, y equal number, y equals x number. So they don't line up. Okay, so we're gonna have to change this up. Now the question is, what do we change it to? Because we have to make them, both of them, in the same order. So the question is, which one do we put them in? So it looks like this one's not in any form, and this top one is in standard form. So I'm thinking that we could just change the order of this bottom one. So I'm gonna have to minus 2x from both sides. And that should give us a new equation. So negative 2x plus 7y equals, and since we canceled out 2 here, it's going to be 8. Okay, now I'm just looking at these two here, the 5x1 and the negative 2x1, where that's the number they start out with. Now in this case here, it looks like I'm going to have to change both of them again. Now looking at y, 6 and 7, there's no other numbers that they could meet up at other than just multiplying 6 times 7. But if I have 5 and 2, I can make them meet up at 10. So that's what I'm going to do. I'm going to have them meet up at 10. So I'm going to double this number. So I'm going to just put times 2. So 10x minus 12y equals 6. So I just doubled all of these numbers in this equation here. And for this one, it looks like I can also double it. I don't need to multiply it by a negative, or I'm sorry, not double it, quintuple it, times it by 5 essentially. Because since it's already negative, it's going to come out to be negative 10, and that's going to cancel out the x. So 5 times 7 is 35. Equals, and then 5 times 8 is 40. Now I'm going to go ahead and put these two together, combine them. So 10 is going to cancel out. And let's see, for y, we're going to get 35 minus 12. So 5 minus 2 is 3. And 3 minus 1 is 2, so it looks like we get 23. And here it looks like we got 46. Just 40 and 6, put them together. And just to save some space, what number times 23 gives me 46? Well, it's quite obviously you would need to double it in order to get the next number. So y equals 2. All right, that one's took a little bit of work. But from here, you would just plug it into one of the originals. So since I have y, it wouldn't make sense to put it in here because then I'd have my number on one side. So I'm going to put it on the top one because I'm still going to have to, it's the x that I'm after. Since in this case, it's a little bit, again, it doesn't really matter too much, but I'm gonna plug it into this one. So 5x minus 6 times 2 equals 3, because I plugged 2 in for y. And let's go ahead and work on this. So 5x minus 12 equals 3. Add 12 to both sides. And 5x equals 15. And I know this one here. X equals, because 5 times what gives me 15? Well, 5 times 3 gives me 15. Now I have both my both of the points for the coordinate pair. And let's go ahead and put that together. So x is 3 and y is 2. And did I do that on the last one? Yeah, it's not that important. Oh, okay. Just have to make sure I'm boxing my answers. Okay. Oh boy. All right, let's go ahead and get into number 8. And we got to check the order, which in this case, I know some students looking at this would be like, oh, that's already in order. And no, it's not, because the x is the first one, but in the second one, the x is the second one. So again, you got to make sure they're in the same order. So in this case here, it looks like I'm going to have 9x. All I'm going to do is just switch the place of the x and the 4. And then, again, I don't scratch it out, but I'm just going to do that to help me ignore it. And okay, now I got to decide which one I am going to eliminate. Which one should I eliminate? So I'm going to go ahead and multiply this top one by 5 and multiply this bottom one by 8. Now, the reason I didn't choose x is because if I don't have to change the sign, and again, sign changes are one of the biggest places that people will forget things, forget to change the sign. So I'm going to just avoid that by not changing the signs. So it's easier to multiply things. Like in this case, I'm multiplying everything by 5. Okay, so 5 times 18. So half of 18 is 9. Double 5, that's 10. So 10 times 9 is 90. Or, wait, is it 90? 5 times 18. Oh well, keep going. 5 times negative 8, so that would be negative 40y. And now for this side, I'm going to multiply everything by 8, so that'd be 72x. 8 times 4, so that's 1632. And 18 times 5, I'm sorry, 8 times 5 is 40. Whew, okay. Now in this case here, y should cancel out. Since I don't have anything left on that side, I guess I'm going to put an equals 0. And that happens. Sometimes I get students that do that and they're just like, well, what do I do if there's nothing on the other side? Well, don't worry about it. And let's see what we got on this side here. 50 and 70, so 0 plus 2. Oh, I almost forgot the x here. Now, what number can I times by 122, add 122 to get 0? All right, so okay, that's kind of an unfair question. Let me go ahead and minus 122 from both sides. So 122x equals negative 122. Now in this case here, I'm going to divide both sides by 122. I mean, I could have already seen what it was, but I don't want people asking, where did I get that from? So there we go. We got x equals negative 1. Now let's go ahead and take that and plug it back into one of the originals. And I'm just going to grab this bottom one here. I don't know if that's the best one. I'm just going to grab it. It has the smallest numbers, so it'll probably work out fine. 9 times x, which is negative 1, equals 5y. So 4 minus 9 equals 5y. 4 minus 9. 4 minus 9 is negative 5. So what number can I times by 5 to get negative 5? Well, I just need to make it the opposite. So if I divide both sides by negative 1, I get y equals, now negative divided by negative is going to be canceling that out. Well, actually, I don't really need to divide by a negative. But we are still going to get negative 1, it looks like. So negative 1, negative 1. Kind of looks like an electrical socket. Okay, now that I said that, everyone's going to not be able to unsee that. All right. Again, a bit of work. That's okay, though. Sometimes things just take a little bit of work. As long as you expect a little bit of work, you'll never be disappointed. Okay, moving on to the next thing is applications. So we got to find out what we are working for, set up the equations, and solve. So basically, it's just what it's still going to be what we've been doing. All right. So, and we've already had a couple of these where we were like the ones we were solving with the dimes and the quarters, or the nickels and the quarters, kind of like that one. So we're going to have to set up the equation and work it out ourselves. Okay, Marcy bought a total of 20 used books and CDs during a yard sale for a total of $54.50. Man, I remember when people had to go to the music store to get CDs. And people would be like, hey, man, can you make me a CD? Burn me a CD, man. That was a long time ago. And I remember my buddy had one that only burned one song at a time on each track. Anyway, man, how times have changed. Anyway, so if the books are $1.50 each and the CDs are $5 each, how many of each item did she buy? All right, so seems not so bad. So bought a total of 20 books and CDs. So to set this up, we're going to have two parts, and that is the quantity and the value. Now, you could probably figure this out without this, but I'm going to kind of give you this to make it a little bit easier. So quantity is how many of each there were. So we'll just say book is B and CD is C. Now, it doesn't matter what it costs. If you buy one book, that's one book. 5 books is 5 books. It's not going to change anything. CD, same thing. It could be anywhere. We could have bought 11 books and 9 CDs or something like that, but it has to come out to 20 items. For the value, now we have to get into how much they are. So the books are 150. So 1.5B. So if we buy one book, it's $1.50. If we buy 2 books, it's $3. 3 books is $4.50, and so on. Plus C. Let's see. C is CD. So they're $5 each. So for each CD, that's going to be $5. So again, 1 CD is $5, 2 CDs is $10, 3 CDs is $15, and so on. Now to get this part, we're still talking about the value. So the total, not the total items, but the total sale values, sale price, $54.50. Now in this case, we are going to have to multiply some things out. So what I'm going to do is I'm going to pick one of these. Now, since I want to avoid decimals, I don't want decimals. I could multiply this by negative 1.5, but I don't want to do that. So what I'm going to do is I'm going to multiply everything by negative 5. So multiply everything by negative 5 on the top one. So that's negative 5b minus 5c minus 100.0, just to help us see the decimal, because I know if I don't put the decimal, some students are not going to line it up. Now, again, I times everything on the top by 5 and flip the sign, and I'm going to use these bottom two here. And I did that because I want the C in this case to eliminate. So in this case, I get negative 5. Now, if you let's say you have $5 and you buy something for $1.50, that's going to be about $3.50 left over. So negative 3.5 equals negative. Now for this one here, I probably should use a calculator. No, I probably don't need to. It'd be 45.50 is my guess. 45.50, and I don't have my phone on me, so I don't have a calculator that I could use, because this would be a lot easier if I did have one. All right, I think I got one here. You can't, I don't know if you can see it or not, but okay, 45.50 is correct. Divide that by 3.5 and I get 13. Now I forgot the B here, so B is 13. There you go. Now since they're both negative, it doesn't make sense to say that. But now we know there are 13 books. And this is a pretty easy one because on the top one, right, that's the number. They have to add up to 20. So if there's 20 items and 13 of them were books, then how many of them were CDs? Well, the CDs, that has to be 7. So we should plug it in, but in this case, it was so easy because it's like 13 plus 7 is the only combination that would make 20, because you can't buy half a book, you can't buy half a CD or any portion of a CD. Right? They're not going to let you buy part of it. And even if you did, I don't think it would even work. Like, I'm sure some of you remember CDs like when you were really little, but if you get the smallest nick on them, the smallest scratch, the whole thing is just sort of messed up. You can't use the CD anymore and you get skipping tracks. Kids these days will never know the pain of having to drive your truck off road and trying to listen to the CD player in your car. Okay. Not too bad. Landon, okay. Oh, like Lando no, it's Lando. Landon. I don't think I've ever met somebody named Landon. That's a new name for me. Landon babysits and works part-time at the water park over the summer. So 1 week he babysat for 3 hours and worked at the water park for 10 hours and made $109. The next week, he babysat for 8 hours and worked at the water park for 12 hours and made $177. How much does he make at each of his jobs per hour? This one's a pretty easy one. Both sentences, both of the clue statements, so every single word problem has an introduction. So he works at the water park and babysits. That's the introduction. Tells you what to expect. He babysat for 3 hours. So we'll put 3 for babysitting. And 10 for, I don't know, water park. And he made $109. And the next week, so it's the same thing, babysat for 8 hours. Water park, 12 hours. Well, that's a long, well, actually that's a whole week, so probably not that much. But if I say 12 hours, when someone says I work 12 hours, and my first thought is, oh man, that's a long shift. So there's our second clue statement, 8 hours at the babysitting and 12 at the water park, and he made $177. So how much does he make at each of his jobs? So how would I tackle this one? Now I would have to multiply, I could make them both 60 here, but then I'd risk making the numbers really big. So I'm going to kind of keep it simple. And I am going to multiply this one by -8 and multiply this one by 3. So I'm going to do this one first. So -24b plus, actually it'd be negative because I'm multiplying a negative. So 80w. And I'm going to go ahead and 109 times 8 and that'd be 872. All right, and then double check the signs. Oops, that's why we double check it, because again, that's usually the biggest thing that happens with these is make sure that you don't miss the sign. All right, now let's go ahead and triple this one. So 24b, which they match and are opposite. That's what I wanted. And plus 36w. 3 times 12. Yeah, 33 times 12 is 36. Equals, and 177. Bring up my calculator again. 177 times 3. That'd be 531. Negative 531. Oh, not negative. Or is it? No, okay. Not negative, I'm getting a little bit carried away. So again, double check your signs because it really is easy in this to switch a sign or miss a sign. Okay, so everything looks good. Let's go ahead and put them together now. Okay, so that should cancel out the B. And 80 minus 36, so that'd be 44. W equals, and just to make this go a little bit faster, again, I'm gonna get the calculator back out. So 531 minus 872, and that'd be negative 341. And I'm gonna see if I can easily divide this by 44, I'm sorry. And we get W equals 775. And that makes sense. Sometimes when it comes to word problems, I call it the sniff test. All right, sometimes you can tell something's wrong just by giving it a little sniff. And $7.75 makes sense. Now, this worksheet was, I'm looking at my copy here. It looks like it was written in 2015, and back in that time, $7.75 was probably a very good price. A good wage for hourly rates. So this makes sense. I mean, nowadays it seems kind of low, but that's just because, well, since this problem was made, minimum wage has been kind of going up and up. So makes sense. In this case, someone might have said, well, 5 years ago when I had a job, that's what I made. So now we have to plug it back into one of these. So let's go ahead and do that. So W is, now I'm going to plug it into the top one because it's got a 10 right there. Timesing things by 10 is really easy. And it's so easy, in fact, I'm just going to go ahead and put 77.5 because, again, to times anything by 10, you just move the decimal. So that was super easy. That was like an easy choice for me. So again, I just put $7.75 in here, $7.75, and times it by 10. All you got to do is just move the decimal over, and that's it. And that was so easy for me. I just didn't even have to do anything really all that much. Now again, I'm kind of using the calculator a lot, so why not use it again? 77.5, and that becomes 31.5. So 3B is 31.5. So if we were to take 3 hours of his babysitting job, he would have gotten $31.50. And again, I could probably just use my calculator for this again, and that's 10.5, and that makes sense. Babysitting is a tough job. Babies always try their hardest to hurt themselves. And that makes it a really time-consuming, stress-inducing jobs. Why people choose to have children is beyond me. It takes up all your free time. There we go. Ooh. There we go. $10.50. Now that seems, again, more reasonable, so it passes the sniff test. And I'm sure if we were to plug it back into either of those, it would still balance out. But since if I wanted to check this, I would just plug these into the bottom one, because we already know it works on the top one. We just did it right here. So if we wanted to double check this, we would have to plug it into the bottom one and see if it works out. Okay, so we got that one. Let's go ahead and move on to the last one. Kent has a collection of pennies and nickels with a value of $1.98. Okay, so this is pretty easy. So pennies are 1 cent, written like, oh, excuse me. Nickels are written in dollars like that. So that's N equals $1.98. Okay, that was super easy. There was no introduction statement. And we've already seen a problem like this before. So again, we have one side that is the value, and the other side is probably going to be the quantity. Now this one's a little bit of a tougher one because it says here the number of pennies. So pennies is 5 less than twice the number of nickels. Okay, well, this one might have to take a little bit of thought, but number of pennies. So pennies equals, and again, when I say number of, that means quantity. So quantity of pennies is, now is means equal sign when you're translating it. So right here, pennies equals is, number of pennies is, or equals 5 less than twice the number of nickels. Now this one's a tricky one, because less than, if you remember, okay, so you'd have to go back in one of my other lessons when we were first introducing equations with word problems. The less than is the tricky one, because less than means minus, you're minusing that number. 5 less than twice the nickels. So if we have twice the nickels, lessen it by 5. Now this is not in the form that we need. So they are in different orders. So in this case here, it looks like I'm going to have to now, okay, so plug, if I line them up, I'm going to have to do a lot of multiplying. And this actually doesn't make a lot of sense to use elimination. But it just occurred to me right now that we already have P by itself. It's already solved. So I'm not going to listen to the directions and use elimination method, all right? Can't stop me, free country, you know. No, I'm kidding. But, you know, I'm going to use substitution, because it looks like, again, if I had to multiply this out, trying to get something to be 0.05, you know, that's going to take a lot of work. And I'd have to change both of them. I'd have to change both equations. I'd have to change this one so it's in the right order, and then I'd have to change both of them by multiplying one by like negative 100 and something to get them to match up. But let's see if this is going to be a little bit easier. Multiplying this is going to be pretty easy. 5 times 0.01, okay, and plus 0.05. N equals $1.98. All right, so I just distribute that, which again is pretty easy. You just put a 0.00 in front of both of those, 0.0. And let's go ahead and put them together. So let's see, 0.07 N equals, and I'm going to add, I got to get this out of here, so I'm going to do this at the same time. 0.05, and this would be okay, 8 plus 5 is 13. Carry the 1 and carry that again. We get $2.03. Now, this is not the actual number amount of money, so it doesn't really have any bearing on what it is. But let me go ahead and divide that. So 2.03 divided by 0.07. And this in case says that we have 29 nickels. And that makes sense. So 29 nickels, now you can't have half a nickel. And that's a good question. I know if you rip $1 in half and you bring, you know, the better part of $1 into a bank, they will give you a full dollar back for it. But what happens if you get portions of a coin? I mean, I know it doesn't happen, but still, now I'm curious. All right, so let's go ahead and use the other clue statement. The number of pennies is equal to double the nickels minus 5. So now we know we have 29 nickels. So let's plug it in there and see how many of those we have. So that'd be 60 minus 2, so that'd be 58 minus 5. So the number of pennies would be 53. 8 minus 5 is 3, so that'd be 53. So now we have them both. And you know, one thing I should have been doing with these is I should have been writing them out. We could put something like this: nickels is 29 and pennies, oopsie, ponies equals 53. Something like that would have been helpful. I should have done that for all of these questions. Yeah, so just go ahead and do that when you get when you're doing the assignment. Just write them out like that. Now, I sometimes forget that I can type on my computer, so I haven't been doing that. So for this one here, if I were to go back and do this one here, you know, I could just do something like let's see, water park. Is water park one word or 2 words? Okay, it looks like they used 2 words here, but I'm going to use 1 word. So water park is $7.75 and babysitting, babu, is 10.5. And since it's a dollar amount, I'm put a 0 in there. You know, something like that. Something like that would be a lot easier. And then just box that. I should have been doing that this whole time, but I wasn't. Anyway, I guess that's it for today. Parent-teacher conferences are tomorrow. Hold on, let me. Anyway, that was it for the announcements. That will be it for today. As always, I'll be around for questions for another minute if you have any other questions. But if there's nothing else, bye-bye for now. See you tomorrow. We will have class tomorrow. It's just going to be early dismissal, so shortened classes.